Hey guys, today we're going to be solving systems, okay, and this is just day one, so we're actually going to be doing this a few days, so you guys should get the hang of it. There are 3 different ways to solving a system of equations, and the 3 different ways are 1 by substitution, 2 by elimination, and 3 by graphing. Now these are all good methods depending on how the equations are given to you. You can solve any system using any of these 3 methods though, okay? So basically you'll be able to pick whichever method you want to use after today. So today I'm just going to show you all 3 different methods. So example 1. So notice here we have 2 equations which makes it a system, okay? And we're going to solve this one by substitution. So remember when we substitute, we basically, something takes the place of the other thing, okay? So like if I was, like when I have a substitute teacher, right? That means there's somebody else taking my place. It's the exact same concept here. Now, what I can see here is that I have y equals x plus 3. So I can circle this right here because I know that y is x plus 3. So what that tells me is I can take what I just circled and I can substitute into the second equation where I see the letter y. So the new equation that I'm going to write is going to be x plus 3 plus 5 equals 2x. So notice all I did there was I took this y and I basically got rid of it and put what's inside of my circle in that same exact spot. Now this is basically solving because now I only have one variable. So I'm going to put a line down my equal sign. I notice that I have a 3 and a 5, which I know I can combine like terms. So we get x plus 8 equals 2x. Now I notice that I have variables on both sides and they're the same, so that means I have to unite them together. So I'm going to move the 1x to the other side by doing the opposite, which would be to make it minus 1x. What I do to one side, I know I do to the other side. Okay, so what do I end up with? Notice these canceled out, and I bring down the 8 equals 2x minus 1x is just x. So notice I have my first answer, and that is that 8 is x. Notice I'm writing this like an ordered pair, which you guys know the first number is x, and then it's y. Well, now that I know that x is 8, I can figure out what y is a lot easier by using this first equation, okay? So I'm going to use this first equation. Y equals x plus 8. Notice I can substitute, right? Because what do we know x is? We know that x is 8. So I'm going to rewrite it to say y equals, what is our x? 8. And I made one little typo, didn't I? That's not supposed to be an 8 there. It's supposed to be 3, because that's what it says in the problem. Alright, so 8 plus 3. Y equals, well, what is 8 plus 3? 11. So our answer is 8, 11, because I want to write it in an ordered pair as a point. Alright, now let's try this a different way, and that will be by elimination. So we're doing the exact same problem, but by elimination. Now, to eliminate, we have to make sure that everything is lined up together. So we want everything to be lined up with each other. So what that means is anything with the x needs to be x on top of x, y on top of y, equals on top of equals, and a number on top of a number. Now, it can be in any order, okay, but it needs to be where each one is lined up one on top of the other. So if you notice here, I already have in the second equation, we already have y plus 5 equals 2x. Okay, and I want to leave that equation alone because if I look at the first equation, the only thing that I need to move to put this in the right order would be the plus 3 to move it to the left side with the y. Well, how do we move things across equal signs? Hopefully you said by doing the opposite. So I'd actually make that a minus 3. So what I'll have here is y minus 3 equals x. Now to eliminate, we usually look to add, okay, these equations together to eliminate something. But in order to eliminate something, it has to have the same number, but one's got to be positive and one's got to be negative. Now if you notice here, our y's both have the number 1, but they're both positive. So that means we need to make one of them negative. So let's say we decide to make the second equation negative. So that means I have to multiply the whole second equation by -1. So let's see what we get for our new equation then. So -1 times 1y gives us -1y. -1 times -3 is +3 equals -1 times x is -1x. And I'm going to bring the other equation over on top of it. 1y plus 5 equals 2x. And now we can add these together. Alright, so 1y plus -1y is going to cancel out or eliminate, which is what we want. 5 plus +3 is 8 equals 2x minus 1x is 1x. So notice we end up with our first answer, which is x, and that's 8. Remember, we're writing our answer like a point, x comma y. So there's our first answer. Well, now all we have to do is substitution. Okay, so let me erase this work here so that I can have some space. Now we can pick whichever equation we want to use to substitute x for 8. So I'm going to use the first one again because I think it's the easiest. Y equals x plus 3. Well, we know that x is actually supposed to be the number 8. So y equals 8 plus 3. So when we add 8 plus 3, we get 11. So notice our answer is 8 comma 11, which we actually end up getting the exact same answer that we did on the previous slide when we did substitution. So it still proved to work out the same way. Now let's solve the exact same question by graphing. Now, in order to solve by graphing, both of our equations have to be in slope-intercept form, which you know is y equals mx plus b. Are any of our equations already in slope-intercept form? Hopefully you said yes. The first one is. So that equation is already good to go. Okay? But the second equation isn't. We actually have to do some work for the second equation. So we have y plus 5 equals 2x. First I box my y, and I cancel the plus 5 by subtracting 5. What I do to one side, I must do to the other side. So we cancel what's beside our box. We get y equals 2x minus 5. So there we go. We have both of our equations, and both of them are in slope-intercept form. So now we need to graph them on this graph here that we have to the right. But in order to do that, we have to know two things. What is the slope, and what is the y-intercept for both of our equations? So let's look at the first equation, the one on top here. What is our slope? There is no number next to x, so we know that's the number 1. And to write 1 like a fraction, it would be 1 over 1. My slope is going to tell me how to rise over run, and I would be going up 1 because it's positive, and then to the right 1 because it's also positive. My y-intercept, which is what I begin with, is 3. Now, the second equation, the slope is 2, but to make that look like a fraction, I put it over 1. So let's see what our directions would be. It's positive 2, so I would rise by going up 2, and then I would run by going to the right 1 because it's a positive 1. This y-intercept, though, is negative 5. So like I already said, we always begin with b. So let's graph the first equation, which has a y-intercept of positive 3. So there's my first point. And according to that slope, I go up 1 to the right 1. So notice I'm plotting quite a bit of points, that way my line looks pretty perfect, okay? So I'm going up 1, right 1. And I can also go the opposite, which is down 1, left 1. But once I have a few points, then I can hopefully be able to draw my line a lot better. Arrows at the ends, notice I extended all the way off the graph. Now let's graph the second equation. The y-intercept is -5. So that's where I begin. And according to this slope, we go up 2 and to the right 1. Up 2 to the right 1. Up 2, right 1. I'm going to keep going. Okay, what I do notice is that this graph, okay, and this happens a lot on our STAAR test, this graph is going to cross outside of our paper here. So we have to think back to where are we? Okay, so right now, where do we have our x? Our x is at 1, 2, 3, 4, 5, 6, 7. So it looks like our x is going to end up being at 8, right? If we go up 2 and to the right 1, right? Up 2, right 1. So we're looking at this point right here. So that's going to be 8. And our y-intercept is going to be looks like it'll be up 1 here, so that'll be at 11. Okay, so that's why we get the same answer, 8, 11, as all the previous ones. I want you to pause the video right now and answer this question. In this first example, which method was the easiest to you and why? Example 2. We're going to actually do this first one by substitution again. Okay, but I do want you guys to notice something. This problem is going to be difficult to do by substitution because we don't have any of the equations that already say y equals something or x equals something. So that means that we actually have to take one of the equations and make it either y equals or x equals. So I'm going to take the second equation and we're going to solve it for y. So as I'm writing this, go ahead and pause your video so that way you can attempt to do this on your own and see if you end up with the same answer for solving for y. So we end up with y equals 1x minus 1/2. So I'm going to circle the part that I need to substitute into the other equation, okay, which is the first equation, and I'm going to substitute that 1x minus 1/2 into where I see the letter y. So when I rewrite that problem, I'm going to get 2x plus 3 times y, and what is that y? 1x minus 1/2 equals 13. So now all I have to do here is solve for x. Now I notice first though I have to distribute on the left side. So I'm going to bring down that 2x because I'm not doing anything to it yet. And I'm distributing a positive 3. 3 times 1x is positive 3x. And 3 times negative 1/2 is negative 3 over 2 equals 13. I then notice that I can combine the 2x and the positive 3x, and that gives me 5x minus 3 over 2 equals 13. First, I box my variable. We cancel what's beside it. I cancel a minus 3 over 2 by adding 3 over 2. What you do to one side, you know to do to the other side. So those eliminate, and I end up with 5x equals 29 over 2. I'm going to divide both sides by 5, and we get x equals, and we're just going to write this answer as a decimal. 29 over 2 divided by 5 is going to be 2.9. So now we're going to substitute our answer into the other equation, but let me first start writing the first part of my answer. parentheses, comma, 2.9, comma, because now that was my x. So now we're going to substitute into this second equation here, okay? So wherever I see x, I'm going to change it to 2.9. So when I do this, we're going to get negative 2 times x, and hold on, what's x? 2.9 plus 2y equals negative 1. Alright, well, negative 2 times 2.9 is negative 5.8 plus 2y equals negative 1. First, I box my variable, which is the plus 2y. I move a minus 5.8 by adding 5.8 to both sides. They canceled out over here on the left. I bring down the 2y equals negative 1 plus 5.8 is 4.8. And my last step is to divide both sides by 2. And we get that y equals is 2.4. So our answer here is 2.9, comma, 2.4. By doing elimination. Now, elimination is going to be a lot easier. Remember, you want them to be the same numbers, okay? And one's got to be positive, one's got to be negative. And remember, we want them lined up together. So if there's an x here, we want an x underneath. If there's a number here, we want a number underneath, okay? Or if there's a y here, we want a y underneath. So it has to match up properly in order for this to work. If you notice, we do have it properly set up for us already. So we can go straight into elimination. Let's see, do we have to change any of the numbers? No, I have a positive 2 and a negative 2 on the x's, so we can eliminate those by adding. So let's add these two equations together. 2x plus negative 2x cancels out and it gives us 0. 3y plus positive 2y is 5y equals 13 plus a negative 1 is 12. Now let's solve for y. Divide both sides by 5. And we get that y equals 2.4. Okay? So now when I write my answer, notice this is the y value first. So I'm going to make sure I leave some space, put my comma, and then put 2.4, okay, because that's the y value. Now we need to find the x value. So I'm going to pick one of the equations. Let's say I pick the first one. 2x plus 3y equals 13. And I'm going to substitute what I know y is. So 2x plus 3 times y equals 13. Well, what did we discover y is? It's 2.4. So let's solve. 2x plus, well, what is 3 times 2.4? It is 7.2 equals 13. Then I'm going to box my variable, which is 2x. I'm going to subtract what's next to my box by subtracting 7.2 to both sides. Let's see, I bring down my box. I canceled what's beside my box. Equals 13 minus 7.2 is 5.8. And the last step is to divide everything by 2. And we end up with that x equals 5.8 divided by 2 is 2.9. So notice it didn't matter which way we did it, substitution or elimination, we still got the exact same answer, okay? Just to kind of explain what this means, this is basically where the two lines on a graph, okay, where the two lines actually intersect, okay? So what we're finding is that point where they intersect, okay? So that's what gives us our solution for a system. Now let's do this by graphing. Notice we actually already did one of these problems by solving it for y when we did the substitution. So I'm just going to rewrite it. So the answer that we got when we did the substitution was the y equals 1x minus 1/2. Remember, we did that one. So I'm not going to do it again. So just to cut time. So we do need to solve the other equation, though, for y. So I already wrote it down. So I'm going to first box my variable. I cancel what's next to the box by subtracting 2x to both sides. Those cancel out. I bring down my box. So I get 3y equals negative 2x plus 13. Remember, 2x and a 13 can't combine because they're not alike. My last step is to divide everything by 3 because that's the number inside the box. And our answer is that y equals negative 2/3 x plus 13 over 3. Let's go ahead and identify what our slopes and y-intercepts are. The slope here for the first one is 1 over 1, which would mean that we're going to go up 1 and to the right 1. The y-intercept for the first one is negative 1/2. So that's all the information we need to graph for the first one. Now let's write the information for the second one. Okay, and the second one, I'm going to write it underneath the graph. The slope is negative 2 over 3. Which that means that I'm going to be moving by going down 2 and then to the right 3. And the y-intercept for the second equation is also a fraction, 13 over 3. Now that I have that information, remember we can graph it by beginning with the y-intercept, but to be honest, this is really tough to graph. This would be better done if we had our calculator, okay? And when you guys come to class, I'm actually going to show you how to do all of this in a calculator, okay, instead of actually drawing out the graph and having to graph it by hand, okay? So explain which method was easiest for this example, okay, and be sure to explain why. And let's go ahead and move on. Example 3. Write two equations from the graph. So notice they gave us two equations, and we have to figure out what are they so that we can figure out what the solution is. Okay, so for the first equation, let's say the first equation is the red. Okay, first equation is the red. First thing that we should be able to identify is what's the y-intercept. And I see that the y-intercept is right at that point, which is 6. Now, in order to find the slope, we need one more point. I do see a point right here at -1, +4. Now, if I have 2 points, we can figure out what the rise over the run is. So let's see how are we going to move. I'm going to go up 1, 2. So I go up 1, 2. So I went up 2, and then to the right 1. So up 2 is +2 over 1, which is the same thing as 2. So what would be the equation then? Well, the equation then, okay, if we put it in the proper form, is going to be y equals mx plus b, which is y equals 2x plus 6. Now let's look at the second equation, which is going to be the blue. Okay, so we're looking at the blue equation. First, identify the y-intercept because that's our starting point. And that number seems to be at +4. Now, to find a slope, we need one more point, and I'm going to pick this one, which is 2, 6. So let's figure out what our rise over run is. Okay, so what do we see? Well, I see that I have to go up 2 and then to the right 2. Well, up 2, right 2 is the same thing as saying +2 over +2. And what is +2 divided by +2 reduced to? 1 would be correct. So the answer here, if we put it in slope-intercept form, is y equals 1x plus 4. So now that we did that, the question really is, well, what is the solution? Okay, what is the actual solution here to our problem? Well, let's see if you remember what I talked about. Where do you find a solution when you have a graph? Hopefully you think that it's probably around this area right there, right? Remember, we always find the solution where the 2 points intersect, okay? So that's where we find our solution. And what point is that they intersect at? -2, 2. So that would be the solution. So, kind of already answered this question, right? Where do we find the solution? Make sure you write it down. Where the 2 lines intersect. What is the solution for the system? We already wrote that down. So please make sure that you write it down again over here, okay? And make sure you wrote down where do we find solutions. Now, explain which of the 3 methods, okay, you like best. Remember, the 3 different methods were substitution, elimination, and graphing. I think most of you guys are going to like graphing, especially when you guys come back to class and you're actually using the calculator to help you, okay? But whichever one you like best is the one that I want you to stick to. Hopefully you guys enjoyed this lesson, and see you guys later.